12.1, tangent lines. A tangent is a line in the plane of a circle that intersects the circle in exactly one point. The point where the circle and a tangent intersect is referred to as the point of tangency. So in the example here, BA is a tangent to the circle here, and the point of tangency would be point B. Here we're presented with a theorem that says if a line is a tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So if you have a tangent line and you have a radius, they will meet at a right angle. So a line tangent to the circle and the radius that meets at that point of tangency are perpendicular. If ML and MN are tangent to circle O, what is the value of x? So we're trying to find the value of x. Well, keep in mind that ON and OL are radii, and MN and ML are tangent lines. So that means these angles here have to be 90. Well, if we think about the shape that's created by the tangent lines and the radii, it has four sides. So that means it has an angle sum of 360. So to find x, we're going to take 360 minus 117 minus 90 minus 90. And in this case, we figure out that x equals 63. In example 2, ED is tangent to circle O. What is the value of x? So once again, we have a radii from O to D and a tangent here in ED, so this should be a right angle. A triangle adds up to 180, so to find x, we're going to take 180 minus 38 minus 90, and that's going to give us x. Well, in this case, x should equal 52. So x is 52. Jasmine is riding in an airplane at an altitude of about 6.5 miles above Earth. How far from Earth can she see if the Earth's radius is about 4,000 miles? Okay, so if we think about it this way, let's put the plane here. And so that means that this height here is the height above the Earth, so 6.5 miles. The radius of the Earth is 4,000 miles. And we're essentially looking to see how far along this line can she see. Well, we're looking for x. Well, if we're dealing with a right triangle here, one of the things that comes to mind to use to solve this would be the Pythagorean theorem. So let's try to set that up. We have x squared plus 4,000 squared equals, well, in the hypotenuse's case, it's this entire length, so that would be 4,006.5 squared. I'm going to square the 4,006.5, and I'll square the 4,000 on the other side, and I'll subtract it over. At this point, I'll end up with x squared equals 52,042.25. So the last step will be to square root both sides. And we get x equals 228.13 miles. So Jasmine can see 228.13 miles on the horizon from a height of 6.5 miles above the Earth. If a line in the plane of a circle is perpendicular to the radius at the endpoint of the circle, then the line is a tangent of the circle. So this is actually just the reverse of what we saw earlier. Now they're saying if you have a line that meets the circle and is perpendicular to the radius, then you can say that that line is the tangent of that circle, or is a tangent of the circle. So here they're asking, is ML tangent to circle N at L? Well, to test to see if this is perpendicular here, we're looking to see if this is a right angle here, we pretty much have to prove that this is a right triangle. And to do that, we use the Pythagorean theorem. So if these measurements satisfy the Pythagorean theorem, we know we're dealing with a right triangle, which means that that would be a right angle. So let's test it. 7 squared plus 24 squared equals 25 squared. 7 squared plus 24 squared, when you multiply it all out, you get 625. 25 squared is 625. So in this case, it satisfies the Pythagorean theorem. Therefore, this is definitely a tangent, because we now know that those are perpendicular. The radius is perpendicular to the tangent. Question 2 will do the same thing. We've got A, B, and C, and we're going to test the Pythagorean theorem here. So we've got 12 squared plus 5 squared equals 13 squared. In this case, this is 144 plus 25, which is 169, which in this case equals 169. So in this case, once again, this is a yes. This question asks, what is the radius of circle C? And so we're looking for the x values here. We're going to do the same thing we just did, except we're not trying to prove the Pythagorean theorem, we're just trying to solve it. So this side here would be our A, this would be B, and the entire length here is going to be C. So we've got x squared plus 12 squared equals x plus 8 squared. And this is where we're going to have to remember some of the Algebra 1 topics, FOIL, that you learned last year. So on the left, we just keep x squared plus 144. But on the right, we're going to FOIL this out. And when we FOIL it out, we get x squared plus 16x plus 64. And now we need to try to solve for x. So let's try to get the x's on one side, everything else on the other. So I'm going to bring this x squared over. Those are going to cancel. Got 144 equals 16x plus 64. I'm going to go ahead and subtract 64. So now I've got 80 equals 16x, and then I'll divide by 16, and I end up figuring out that x equals 5. So the radius in this case is just 5. Question 2, very similar. We're going to use the Pythagorean theorem again to help us figure out the radius of the circle. So we've got A, B, and all of this is going to be C. So that's x squared plus 24 squared equals x plus 18 squared. So we'll go ahead and multiply out the left the best we can. This gives us x squared plus 576 equals x squared plus 36x plus 324. So once again, we're going to try to get everything, all the variables on one side, everything else on the other. So I'll subtract x squared from both sides. That gives me 576 equals 36x plus 324. I'll go ahead and subtract 324 from both sides. This gives me 252 equals 36x. Last step would be to divide by 36. And I'm going to get x equals 7 in this case. So the radius of this circle is 7. In this theorem, it states that if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So in this case, AB and BC are both tangent to circle O, and they meet at endpoint B, so therefore they must be congruent. O is inscribed by triangle ABC. What is the perimeter of triangle ABC? Well, based on what we just saw, since we know that this segment here shares a common endpoint with this tangent here, they should be the same, so we can make AF 10 as well. And then FC is tangent the same way that CE is, so that means this segment here is 8. And then on the other side, we've got DB and BE, which are congruent, so this would be 15. So now all we have to do to find the perimeter is add up all the sides. So 10 plus 10 plus 15 plus 15 plus 8 plus 8. And we're going to figure out that the perimeter of triangle ABC is just 66 centimeters. Question 2, very similar. It says O is inscribed by triangle PQR. What is the has a perimeter of 88 centimeters? What is the length of QY? So this time we're working backwards, and we know that the total perimeter is 88. So let's go ahead and see if we can figure out any other measurements. Well, XP and PZ should be congruent, so this would be 15. XR and YR are congruent, or sorry, ZR and YR, are congruent, so this is 17, but we don't know what QX and QY are, but we do know they're the same. So we can just say this is X and this is X as well. So what we can do is we can take the total perimeter of 88 and we're going to set it equal to everything we know. So we know 15 plus 15 plus 17 plus 17 plus, in this case we have 2x's, so 2x. And now we're just going to solve this to figure out what those measurements would be. So this simplifies down into 64 plus 2x equals 88. We're going to subtract 64, so we get 24 equals 2x. And in this case, x equals 12. Therefore, we get that QY has a length of 12 centimeters. Here it says circle S is inscribed by triangle LMN. What is the perimeter of LMN? So once again, we know that if this is 8, this is 8. If this is 5, this is 5. And if this is 14, this is 14. So once again, to find the perimeter, we just add them all up. So 16 plus 10 plus 28 is going to give us a perimeter of 54 units.